Okay, so here's everything that I could think of that might potentially be on a test, and of course it may not cover every little thing, but this is a good chunk of the chapter, and if you can do this, you can do pretty much anything. So, all right, so for the first two, you're given an angle, the first one in degrees, and we're going to charge through all of these parts. So what quadrant will the terminal side lie in? Well, that just means, you know, where is this angle? So if this is 90 and that's 180, then it's going to be quadrant 2. Okay, part B, a positive and a negative coterminal angle. That's just adding revolutions. So since we are in degrees, we're going to take this angle and we're going to add 360. Then we're going to subtract 360, and then whatever those answers are your answers. So I'm getting a 497 is one of them, and then if I subtract from 360, then I've got 237, 337, what is that, 40, 50, I think that's right, 60, yeah, that should do it. Okay, so those are my two angles. And then part C, find the reference angle. The reference angle just means what are you similar to in the first quadrant. Now 137 is somewhere in here, and it's like basically if you could flip it over here, where would you be? And the way that you find that is you hunt for that angle which is congruent to that angle. So you always just want to look for how far are you from the x-axis. So if this is 180 and this was 137, then I can just take away those two numbers, just subtract, and I'll get my answer. So the reference angle for this is 180 minus 137, whatever that is, 40, 50, 60, 70, is that 43 degrees? So that should be my answer. All right, part D, find the complement and supplement. Complement just means that two angles that add up to 90. Now, this one for complement, it does not have a complement, okay? I'm just going to put nope. It doesn't exist. Why doesn't it exist? Because this is already greater than 90 degrees. So you can't have a complement to add up to 90 because you're already bigger than 90. Does it have a supplement? Yes, because supplementary, remember, adds up to 180. So I just need to decide what's the supplement to add up to 180. I've already done that math earlier, and it was a 43 degrees. Okay, part E, convert to either radians or degrees. Well, it looks like, I mean, I'm in degrees, so this is asking me to convert to radians. So when you want to convert to radians, you just multiply by pi over 180. And if you have a calculator, I recommend, you know, don't touch the pi. Leave that alone. Just reduce your fraction here. And I don't think this is going to reduce. I don't think anything goes into 137 and 180. So for me, that would be my final answer. Okay. Moving on to number 2, same exact stuff, except now it's a radian. So what quadrant will I lie in? There's a couple ways to do this. I think if these are hard for you, what I would do is just take the ones that you've memorized, which are pi and pi over 2, and this is just 0 or 2 pi. Okay, so I would take these and try to figure out where this goes by getting common denominators. In other words, this is a common denominator of 5, right? So I would ask myself, you know, looking at this, what would I do? I think I would actually write this as a common denominator of 10, and I'll show you why. If I get a 10 on the bottom here, then that means that this is a 4 pi over 10. And these are the same thing, right? I just multiplied both top and bottom by 2. And the reason I'm doing this is because now I can come over to these and put them all over that same denominator. So I'll get that same common denominator of 10, so that would be 15 pi over 10. This would be, if I turned a 2 into a 10, that would be a 5 pi over 10. Okay, so now I can see that 4 pi over 10 would be a little bit less than 5 pi over 10, so it's probably right here, and that would be quadrant 1. That's probably how I would do it. I know it takes a little bit of time and thinking, but it works. Just get common denominators between the 2's and the ones and whatever you see here, and once you make everybody common, then you can figure out where it goes. Okay, positive and negative coterminals are actually pretty easy on this. Instead of adding or subtracting 360, you add or subtract 2 pi. So we need a common denominator. Right now this is over 1. I need it over 5. So if I make that a 5, that becomes a 10, and then I just add fractions. 2 plus 10 is 12 pi over 5, or 2 minus 10 is negative 8 pi over 5. So those are my two answers for B. The reference angle is how far away you are from the x-axis. Well, since I've already drawn it here and it's already in the first quadrant, it is its own reference angle. So keep that in mind. If it's already in the first quadrant, that's the answer for reference angle. So it's just 2 pi over 5. Part D, the complement and supplement. So it's going to have both, because since it's in the first quadrant, I know that there's a little piece right here that I could add to it to get up to 90 degrees, or what's 90 degrees? Pi over 2. So what I would do is, for a complement, I would take pi over 2 and subtract what I see. So you're going to need to get common denominators. We'll go with 10 again. If that's a 10, that's a 4. So the complement would be 6 pi over 10, which is what? 3 pi over 5. Okay? Did I do that right? Times, oh shoot, that's times a 5. Sorry, that was a 5. I knew that seemed weird. Okay, so that should be pi over 10. My bad. Okay, answer is pi over 10. Or if you need the supplement, instead of subtracting from pi over 2, you need to subtract from the whole 180, which is a pi. So I need to subtract from that to get the supplement. So common denominator math would be 10 pi over 10 minus 4 pi over 10. And I will get, that's the one that's 6 pi over 10. Okay, so 3 pi over 5. So there's the complement, there's the supplement. All right, converting into the other form. Well, right now it's a radian, so to convert to degrees, we are going to multiply by 180 over pi. I'm going to let these pi's cancel, okay? And I've got 2 times 180, which is 360. Divided by 5. If you have a calculator, calculate away. If you don't have a calculator, just do the best you can in simplifying. This does simplify, by the way, because 5 goes in there 72 times, I think. That would be 7 and 1, 2. Yeah, that's right. So do it by hand or do it with a calculator. If it hadn't been an even number and you don't have a calculator, just leave it as a fraction, okay? But if the fraction reduces, you better reduce it. Okay, now comes my favorite part. I'm going to kind of go fast through these because by now you know your unit circle. If you don't know your unit circle, you will not pass this test. Let me say that again. If you don't know your unit circle, you will not pass the test. So make sure that you have looked over it again and again and again. This is going to be a big chunk of your test. I'm guessing a good 25–30%. So you're supposed to know where the cosine of, or where pi over 3 is, okay, and it's right up there. You're supposed to know the point at pi over 3 is 1/2 comma root 3 over 2, and you're supposed to know that cosine means x. So what is the x value up there? It is 1/2, and you are done. The sine of 4 pi over 3, well, 4 pi over 3 is down here in this quadrant. It's going to match this point, and you need the sine. So the sine is the y. The y is a root 3 over 2, but since we're down in this quadrant, it's actually a negative, okay? Cosine of 330, okay, 330 is actually here. It's the one that matches 30 degrees. Those two match. So the point for 30 degrees is root 3 over 2 comma 1/2, which means this one's the same. I need the x value here. There we go, and it's positive because even though we're at the bottom, x's are positive over here, okay? Tangent of 5 pi over 6, okay? 5 pi over 6 is here. Once again, it matches this point. The only difference is you have a negative x when you're in this quadrant. Negative x, positive y. So if I want the tangent, I'm supposed to do y over x. because that's the definition of tangent. So I'm doing 1/2 over negative root 3 over 2. When dividing fractions, you flip the second and multiply. So those will cancel, and you'll get a negative 1 over root 3. Now, some of you might leave your answers like this. Others have been trained to rationalize. So if you rationalize, you multiply the top and the bottom by that radical, and that would be a good final answer on number 6. All right, number 7, secant. Okay, we all know where pi is, and it's over here, and we all know the point that's there. You just got to figure out what secant means, okay? Secant's the reciprocal of cosine, so I need 1 over the x value. The x value is negative 1. 1 over negative 1 is negative 1. Cosecant is 1 over y. It's the one that matches sine, and it says a negative pi over 4. So what I need to do is really think through, okay, what does that mean? Well, a negative means that you go this way, pi over 4. So I'm down in that quadrant, and the catch here is that the y down here is also negative, and it's going to match the pi over 4 from this quadrant. So it's going to be 1 over negative root 2 over 2, which is negative 2 over root 2. If you rationalize that, so times root 2 times root 2, you're going to get negative root 2, okay? So that would be the answer for number 8, either this or that, depending on your teacher. And then cotangent is x over y. So I need to go to pi over 2, which is straight up at the top. The point at the top is 0, 1. I need the x over the y. I need 0 over 1. 0 on top is 0. If 0 had been on bottom, you would say undefined. All right, so that is a huge chunk of your test, just knowing your circle and how to maneuver along with those formulas, x's, y's, and the reciprocals. Okay, now I'm going to go down to, I like these. This is like section 4.3, 4.4. It's just application of all these trig functions. So what we're going to be looking at is a lot of triangles, like the whole last 4, I would draw a triangle for every single one of them. So given that the cosine is 5/8, okay, so before I do anything else, since 5 over 8 is not a memorized unit circle value, I'm going to go ahead and draw a generic triangle, and that's what mine looks like. You always want to pick a corner for your theta, and you have to know that cosine is, you have to know your SOHCAHTOA. SOHCAHTOA. And cosine is a over h, so the adjacent over the hypotenuse. So the 5 is the adjacent, the 8 is the hypotenuse. So you need to start your picture this way. Then you got to know that cosecant, okay, what is cosecant? Cosecant's the reciprocal of sine. So since sine is O over h, then this one must be h over o. You just flip it, okay? So I need the hypotenuse, which is 8. And I need the opposite. Now I don't have the opposite, so I need to find it. So this is just 25 plus b squared equals 64. I'm just doing a little Pythagorean theorem. You should be getting pretty good at these. What's 64 minus 25? Oh, that's going to be 54, 44, I think it's 39. And then b is the square root of 39. Okay, I don't know the square root of 39, so it's going in as the square root of 39. So your answer is here. It's 8 over root 39, or you may rationalize that, and you're going to get 8 root 39 over 39. Yay! All right, so that's how you do something like number 10. Number 11 is going to be the same. The only thing is you're actually in a quadrant now. You have to go to the point -3, -9, which is somewhere down here, and then I would just connect that to the origin. This is your terminal side of your angle, so connect it right here, and then make a right triangle. Now here's the trick. Please, please, please always draw that triangle up to the x-axis, okay? If you go up to the x-axis, then it's very natural to say, oh, okay, well, I know these lengths now, because this is my x. I mean, I'm on a coordinate plane. This is x, this is y. So my x is -3, my y is -9 just by looking at the point that they gave me. Now I'm going to do the same thing. I'm going to go ahead and find the hypotenuse because I'm going to need that to do all 6 trig functions. So the hypotenuse will be 9 plus 81 equals c squared. So I'm getting the square root of 90, or that breaks down to 3 root 10. So I'm getting a 3 root 10 for my hypotenuse, and now it wants me to do all the trig functions. So let me go ahead and list them out. Sine, cosine, tangent, secant, cosecant, cotangent. Okay. Now we can just do SOHCAHTOA with this, okay? If you memorized the X, Y, R formulas, you can use the X, Y, R formula. I'm just going to use SOHCAHTOA because when I have this picture, this is my theta. The inside angle is always your theta, so it's pretty easy for me to go, okay, cosine is A over H, so adjacent over hypotenuse. Now you would want to reduce this. I'm only going to reduce the first one for the sake of time, but you would want to clean all these up. So this is actually a 3 over 3 cancels, right? So you have -1 over root 10. Then when you rationalize, that's going to be negative root 10 over 10. Okay? Sine is going to be the opposite over the hypotenuse, which is -9 over 3 root 10. When you simplify and rationalize that, it looks like it should be a negative root 3 10 over 10. The tangent is the opposite over the adjacent, so -9 over -3 is a positive 3. And then for these 3 over here, remember you just flip what you already have. So I'm going to flip what this was, and it's just going to be -3 root 10 over 3, which means it's negative root 10. This one I'm going to flip right here, and it's going to be root 10 over -3. And then this one's going to be positive 1/3. So I'm just flipping the answers from here to get these others, okay? Number 12, if the angle of elevation of a ramp is 3 degrees, so 3 goes down here, and the ramp is 15 feet long, so the ramp itself is 15 feet long, determine how tall the ramp must be. So I'm looking for the height, okay? So what you want to do is look at your angle, look at what's given, so the hypotenuse is given, and they want me to find the opposite. So which trig function is opposite and hypotenuse? Well, that would be sine. So the sine of 3 degrees, make sure you're in degree mode in your calculator, is the opposite, I'll call that x, okay, over the hypotenuse. And if I want to solve for x, I can just multiply both sides by 15. And so you're literally just going to pick up your calculator and type that in. Make sure you're in degree mode. I don't have a calculator right now, so I don't know what it's going to be, but just type it in and make sure you're in the right mode. And then the last one is given that the cotangent is blah 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 and blah blah blah, find this. Okay, this is, believe it or not, the same thing as these 3. You're going to draw a triangle. The only catch is you need to know where to draw that triangle. So I'm going to use this as my where am I. Okay. Now 3 pi over 2 is down here and 2 pi is over here. So I know that I am in this quadrant. Anywhere. So draw a line through there, like anywhere you want. And we're going to do like we did on number 11. Make a triangle, but it's got to be up to the x-axis. Okay, always to the x. Now that you've done this, your theta is the inside corner. And this says that the cotangent is 6 over 5. So cotangent, remember, is x over y. So that means that 6 is the x and 5 is the y. Now the reason that is negative right there, guys, is because look at what quadrant you're in. So you have to know, where do I put my negative? So should I put it on the 6 or should I put it on the 5? Well, hopefully you see that it should go on the 5 because you're in quadrant 4 and the y is always negative. Okay? Now I need to find my hypotenuse. So 36 plus 25 equals c squared. That's a 1. that's a 61. Beautiful. I love when I make up problems that don't have pretty answers. Square root of 61 is the square root of 61, and that's how we're leaving it, okay? And now we do what it actually wants. It doesn't say find all 6 trig functions, it just says find the sine. Well, the sine is opposite over hypotenuse. So the opposite is the -5. The hypotenuse is the square root of 61. So some of your teachers will let you leave it like that. Some are going to have you rationalize, and that would be -5 root 61 over 61. All right, cool. So that is my best guess for all the stuff that might be asked on the test. I know I did leave off arc length and area of a sector because everybody teaches that different, and I didn't want to confuse you. So go back to your notes and look up those 2 formulas, or however you learned it. Make sure you look at those as well. But unit circle's the key, and when in doubt on anything else, draw a triangle. Draw a triangle, use SOHCAHTOA. Draw a triangle, use your X, Y, and R formulas, or and always remember that whole draw it to the x-axis thing. Most things go with the x-axis in this unit, okay? All right, well, good luck, you guys. We'll talk to you later.